In today's class, we are going to study about principle of inclusion exclusion. Now, this topic is not something new because already you have studied this topic in 2 chapters. Discrete mathematics course, set theory chapter, you have seen this. Engineering mathematics course, probability chapter, you have seen this. So the logics are pretty much clear, the terms you already know, but the problem was the feeling of inclusion exclusion principle. The concept clarity was not there. In today's class, you will get that, plus application of this concept, varieties of question. Also, you will see in the today's class. So let us start the lecture with the very first topic, union. So if I want to find n of A union B, what is the formula? N of A plus N of B minus N of A intersection B, isn't it so? What is this N? This N represents the number of elements, right? Or you may even say it as cardinality of A union B is cardinality of A plus cardinality of B minus cardinality of A intersection B. Now the question, when I was a student, the question that came in my mind is why we are doing addition here and a subtraction here? Why not this addition is good to go since we are doing A union B, which is gathering. So gathering means calling A and calling B together at the same place. So A plus B calling together at the same place. This should be enough. Then why we are doing the subtraction? The reason is, if you visualize this via Venn diagram, you will get the answer. See, when we do n of A plus n of B, right? What happens is n of A is this region, this yellow region which represents number of elements in set A. Then what we have is B set, right? So number of elements in this set B is this. When I did n of A plus n of B, don't you feel blunder happened? Yes sir, blunder happened. This region, which region? Sir, this region was considered 2 times. Therefore the color changed. So unnecessary addition happened. Extra addition happened. So we have to remove that to get the error-free answer. So to remove that, we are doing a subtraction. That's what your inclusion exclusion principle says. That first do the inclusion. While doing the inclusion, you realize you added extra stuff. So in the second step, you do the exclusion of that extra player. So if you do that, then the overall answer is error free and your requirement is satisfied. Understood the inclusion exclusion? So why we did the subtraction? Because this region came 2 times and we needed only 1 time. So 1 time subtraction we did, minus 1 time n of A intersection B. Okay. Now some student will say, sir, here set A and set B were overlapping. What if they are not overlapping? In that case, what is the answer? If they are disjoint, no need of inclusion exclusion principle. Why so? Check it out. Since n of A union B is n of A plus n of B minus n of A intersection B, you have studied. But since these sets are disjoint means they are not in the overlap region. Suppose this is my universal set. This is my set A and this is my set B. Are they overlapping? No. Do they have A intersection B? No. So A intersection B is null. Therefore, number of elements in A intersection B is 0. Now since it is 0, then what is your final answer? N of A union B is n of A plus n of B. That's all. Inclusion is good to go. So inclusion exclusion principle is actually not needed when you have disjoint set. But sir, what if our set is not a disjoint? What if they are overlapping? Then inclusion exclusion principle is the only way to solve the question. Okay. Now coming to 3 sets, A union B union C. If it is disjoint, then n of A plus n of B plus n of C is good to go. But 99%, which means in general, these sets are not disjoint. Okay. So you have to note, if nothing is mentioned in the question, which means overlap regions are present. Okay. If disjoint sets they want to mention, they will mention and you know the answer. But if disjoint set is not mentioned, your mind should say this is overlap region, which means inclusion exclusion principle. So coming to the formula, you know, some students will know, sir, I know the formula, how to get the answer, but never got the feeling, right? So in today's class, we'll get the feeling of the formula. If I need n of A union B union C, the first step is inclusion. So include every player, call A, call B, call C set. So A plus B plus C. Okay. So if you do like this, your A plus B plus C will look like. And you know, while doing the inclusion, extra regions are added. You can see this region A intersection B is included many times, B intersection C also. You can see overlaps are there. So unnecessary, unwanted stuffs are added while doing the inclusion. So second step would be exclusion. So what we'll do is this A intersection B, which is you can see here this reddish line, okay, the A intersection B, I will remove that, okay. So minus A intersection B. So exclusion is going on here also in B and C. This B intersection C is considered many times. So what I'm going to do is I'm going to subtract B intersection C once. So green lines will be gone, okay. Similarly in AC intersection, you can see that many times it is included. So I will now erase one time. So minus A intersection C. So blue lines will be gone, okay. Now while doing the exclusion, I did a lot of exclusion. Can you see there is a space vacant in the middle? Now I am going to do inclusion to fill that vacant space. So you can see that this space is filled using plus A intersection B intersection C. So this is what your inclusion exclusion principle says, that while doing the inclusion you added the unnecessary. So now you do the exclusion. While doing the exclusion, you removed the unnecessary, but you removed also the necessary part. You can see while removing the unnecessary, the necessary part was also removed by, you can say, bad luck, okay. So now in the third step, you have to do inclusion again to fill that necessary stuff. So this is how your inclusion exclusion principle works. And now I hope you got the idea why we used to say n of A union B union C is n of A plus n of B plus n of C minus this thing and addition of this thing. Now I know a lot of students will say, sir, I got the feeling of n of A union B union C formula, but the problem is in the GATE exam, nobody checks our feeling. Everyone checks our answer. So if the question says find n of A union B union C union D, should I go to Venn diagram and get the answer? No. For that matter, if you want to solve in 2 minutes, you should know the tricks, you should know the formula, right? So what's the trick? What's the formula? That's very interesting. Just observe the pattern here and you would be able to generalize. Don't you feel plus minus fashion is going on? These sets are in plus, these are in minus, then plus, then minus. This is what inclusion exclusion principle says. Include, exclude, include, exclude. And the formula says, like the feeling says, while including we included extra, so subtract that extra, but while subtracting the extra we also subtracted more extras. The necessary thing was also subtracted, so that necessary thing you should add again, right? We got the idea. So plus minus fashion, that's the first point. The second point is, don't you feel that the combination of odd number of sets in intersection are in addition, and combination of all even number sets in intersection are in subtraction? I know it got bouncer. Let me decode what I wanted to say. That A set, B set, C set, these are single set. Single means one. Odd set, count is odd, right? So odd sets, if you see, they are in addition. Here also A intersection B intersection C, which means 3 sets. 3, count 3 is odd. So odd set are in addition. And if you see 2 sets, AB, AC, BC in intersection, if you see 2 set, even sets are in subtraction. This is what I meant, that odd sets in addition, even sets in subtraction. But you also heard a word combination. So combination means single set, all the possible combinations you should be in addition, okay. Then in the two set combination of intersections, what are the possible combinations? If you have ABC, it's AB, then AC and BC. Don't say BA because permutation is not asked, combination is asked, right? So A intersection B, A intersection C, B intersection C. 2 set intersection, all the possible combinations you write and then you do a subtraction, right? Then you can see 3 set, all the possible combinations of intersection was only one way, A intersection B intersection C, so it is in addition. So let me give you a general note like this. Only 2 points I made sure that you understood. First is about the sign, that odd sets are in addition, even sets are in subtraction. The second point was critical because intersection is our main focus. So all the combinations of the respective intersections you have to place and then do a sign, right? All the combinations of the respective intersection. If two sets are there, then intersection of two set, all the possible combinations you find, and then you say even is there, so they would be in subtraction. Suppose we have 4 sets, so all the 4 sets intersection combination you find, and then you say even sets are there, so in subtraction. Suppose 3 sets, then all the 3 sets intersection combination you find, and then you say 3 is odd, so odd means addition. Understood? So if understood, then find n of A union B union C union D by yourself, then you look at this slide. Don't you feel the same technique I've used here? First step is starting with the single set combination. A, B, C, D, single, single. So single means odd, odd means they would be in addition. Okay, so all the possible combinations I have written. Then two set intersection, all the possible combinations, AB, AC, AD, then BC, BD, and then CD, right? So you can see AB, AC, AD, BC, BD, and then CD. All the two set intersection combinations, since 2 is even, so in subtraction. Then 3 set intersection combinations you find, you write, then you say 3 means odd, odd means addition, right? So you can see that ABC, and I've written here ABC, then ABD, then ACD, then we have BCD. Only this 3 set intersection combination. Since 3 is odd, so addition. And finally 4 set, so subtraction. This is what your answer looks like. So this is the pattern which you should remember. And the concept part is done. Now to the question. This question you have already solved. I know that in the set theory lecture, in the GATE PYQs, I have solved this, but you will get the feeling now. The number of integers between 1 and 500, both inclusive, that are divisible by 3 or 5 or 7 is what? GATE CS 2017 set 1. If you are trying this for the first time, try by yourself, then look at my solution. I know what is the problem. You will say, sir, by reading the question, I got the idea that event A means divisibility by 3, event B means divisibility by 5, event C means divisibility by 7. So OR means union. They are asking us, can you find a cardinality, since number of integers in this thing. So cardinality of A union B union C. We know the formula. We understood the question, we know the formula, but the problem is, in this question, no data of cardinality of A, B, C, no cardinality of A union B, A union C, B union C, no data of cardinality of A intersection B intersection C. If nothing is mentioned, then even I know the formula, how can I solve? That is the challenge. You have to analyze it and figure it out by yourself. What would be this data? Then you will get the answer. So I know you know the formula. So straight away questions are never asked in the GATE exam. So formula is what? Just to give you the glimpse, this is the formula. N of A plus N of B plus N of C, inclusion, then the exclusion, and then the inclusion. But all these values we do not know. So now we have to get the values. So I will give you a concept first. Suppose I have 1, 2, 3, 4, 5, 6. We have a 6 element set. The length is 6. And if I ask you, find the number of integers in this set which is divisible by 2. Manually you will pick 1 is not divisible by 2, 2 is divisible by 2, 3 is not divisible, 4 is divisible by 2, 5 is not divisible, 6 is divisible by 2. So if I ask you the number of integers which are divisible by 2, 1, 2, 3, 3 is the answer. This is the manual way. Can you do it in method 2 style, something new technique? Sir, I feel that it's kind of this fashion, that the length of this set is suppose n, divide by divisibility by what you need. Here divisibility by 2 you need, so divide by 2. The answer which comes out is the answer of number of integers divisible by 2 in the given set. Can you see they are matching? Now this might, you feel this might be like luck by chance, but no, this is the correct technique. This is the correct technique. You can try by the other also. Number of integers divisible by 5 in this set. Manually you can say that 5, only 1, right? Only 1 is the answer. But if you use this formula that n is 6, divisibility by 5, so 6 by 5 it is 1.2. Consider integer only, so 1 I am considering, so 5. So yes, 1 is the answer, right? By this method also 1 is coming, by manual method also 1 is coming. Also let us try with one more way. Number of integers divisible by 3. Manually you know that 3 and 6, 2 is the answer. Use this method. N is 6 divisible by 3, so 6 by 3, answer is 2. Here also 2. So this works. If this works, now you can find all these players using this technique, because the question says, let us say A set represents divisible by 3, B set represents divisible by 5, C sets represents divisible by 7. You needed N of A union B union C, you know the formula. Given question was, what is the length of the set? Like here, N is the length of the set. So what is the length of the set here? Both inclusive 1 to 500. So the answer is 500. 1, 2, 3, 4 up till 500 is 500, right? If it started with 0, then the answer would be 501, right? But since it is starting with 1 and ending at 500, both inclusive, so answer is 500. Okay, so length we got. So if length we got, can't you find the number of elements? Okay, can't you find the number of elements using this technique? Sir, I can find. So let us find. Number of elements in set A, which means divisibility by 3. What is the answer? Length of the given set divided by 3. Okay, so 500 divided by 3, it is 166.6. take integer only, this is the answer. Then N of B, length by B represents divisibility by 5, so divide by 5, right? So length was 500 divided by 5, completely divisible. C was divisibility by 7. Okay, so length is 500 divided by 7, 71.4. take the integer only, 71. Now what about the intersection? Intersection means commonness. So commonness means divide by both, which means LCM, right? So 500 divided by LCM of 3, 5, because A means divisibility by 3, B means divisibility by 5. So intersection means 3 and 5. So LCM of 3, 5, it's 15. So you can see it is 33. AC would be LCM of 3, 7. BC would be LCM of 5, 7. Intersections would be LCM of 3, 5, 7, right? So if you solve this, this is what you will get. Remember, only integer you have to take. 23.8 means integer is 23. Okay, and here 4. And finally substitute that, you will get the answer. Easy, understood. The principle of inclusion exclusion formula you know for sure, but the challenge in this question was to find the data. Now, suppose I modified the question. The gate question, this is not the gate question, I modified it by saying divisible by 3 or 5 but not by 7. Then what would be the answer? Now, since you know every data from here, you have to just use the concepts to get the answer now. Okay. So try by yourself, then look at my solution. Obviously, let us see the solution now. Venn diagram I am making, and I am saying A, B, C as per the previous data divisible by 5, 3, 5, 7 respectively. Now the question says divisible by 3 or 5 but not by 7, which means not by C. So C region should be excluded, but A and B region should be included. So you can see A, B included, C excluded is this region. But how you will solve this? Sir, I can analyze the Venn diagram and I can say that I need the yellow region, but yellow region cannot be gotten directly since there is no direct formula. But I can use a technique by saying that this complete thing, this complete region, the red region which I am marking, is nothing but A union B union C region. If from that I subtract the C region completely, then what is remaining is the yellow region. So that's how you have to get the answer. That requirement was divide by 3 or 5 but not by 7. So what we said is A union B union C region minus the C region. A union B union C you have found already, which is 271, and C region you also found in the previous slides, which was 71. Subtract that, 200 is the final answer. Understood? So what you have learned from this question, that as per question we have to create formula. There is no direct formula for every question. If understood, try this question. We have 3 sets A, B, C, and the cardinality of A dash intersection B dash intersection C dash is 30. Total universal set is 100. Can you find this thing? Remember that here A dash intersection B dash intersection C dash are nothing but elements not in any set. Okay, elements not in any set. So how you will solve? There are two kind of students. Method 1, I know the formula. from the Venn diagram set theory. Method 2, I will visualize like this using the Venn diagram and I will get the answer. Okay, so let us go with the method 1, the formulas. De Morgan's law says A dash intersection B dash is, remove the dashes and write AB, change the sign and then the whole dash. This is the De Morgan's law. Complement law says A dash is nothing but total minus A, right? If you use these concepts here, you will get the answer. So see carefully, A dash intersection B dash intersection D dash cardinality is, as per De Morgan's law, remove the dashes, so A, B, C, change the sign, so union, union, and the whole dash. Okay, so now this is a complement law. You can say if P dash is present, then it would be U minus P, right? If the complete thing is P dash, then it is U minus P. Now you know very well that what we need A union B union C, right? So A union B union C, you need this two data are given in the question. Universal set is 100, this player was 30, rearrange, you will get the answer. For those students who feel that this is tough, make Venn diagram and get the answer. Okay, so as per the given question, what we needed was this A union B union C, this region, right? And the given data was universal set is given, and what was given? A dash intersection B dash intersection C dash, this is given, right? So by looking at the Venn diagram, I can say universal set is this complete region, and then A dash intersection B dash intersection C dash is nothing but the region which is outside, this region which is outside of this ABC area, this yellow area. So universe minus A dash intersection B dash intersection C dash will give you the answer, which is straight away 70. Okay, 100 minus 30 straight away 70. So Venn diagram helps you to create the formula fast rather than thinking of mathematical formula to arrive at the answer. I am not saying this is something kind of wrong thing to do. It's good if you feel comfortable with this, but this part is pretty comfortable and easy to approach. Method 2, make Venn diagram comfortable to approach. If you don't feel so, try this question. This is the given data. You have to find the number of elements in A only. So no interference of B and C. Here, second question, B only. No interference of A and C. Pause the video, try, then look at my solution. Now, formula is good to go or Venn diagram is good to go? Venn diagram, right? So A only, which is that region, A, B, C overlaps are there. A region means this thing. So don't you feel that if I use my logics, logic says complete A region is this thing. So I have to include this A region. But then unnecessary region is there, so exclude what? This A intersection B. Okay, exclude this. Then also this is unnecessary, which should be excluded, so exclude this also. B, sorry, not B, A intersection C, right? This region is A intersection C, so exclude this. While excluding, you realize this region was excluded 2 times. You excluded extra. So now in the third step, include this region. What is this region? Let me again highlight. This region is A intersection B intersection C. So in the third step, add that and you will get the answer. So I repeat what I did. I needed A only. Instead of thinking of formula, I made a Venn diagram and I was like, use inclusion exclusion principle. Include A completely. While doing that, I realized the extra stuff is added, so subtract, exclude that. So how to exclude? I excluded A intersection B and A intersection C. While doing the exclusion, I realized this region was excluded 2 times. I should exclude 1 time only, but by using this formula, it was excluded 2 times. So extra exclusion happened. So in the third step, do the inclusion. To include this, I was like, this region is A intersection B intersection C, so I will include that thing. And since now direct substitution you have to do the values, you will get the answer. Second question was B only. So how to do B only? Add B, inclusion, then extra things are included, exclude that. So subtraction of A intersection B, subtraction of B intersection C. But while doing the exclusion, this region was excluded 2 times, which is wrong. So we need this like extra exclusion happened. So do addition of this region 1 time. So A intersection B intersection C addition you did and you got the answer. Understood? Try the next question. How to solve this? I hope you have tried this question by yourself and you might be feeling a toughness, or how many terms I have to write here. Okay, let me think how you would have solved. You would have said, sir, since I need the yellow region, first I will do inclusion A plus C, right? A plus C. This is what you have done. Am I right? This is the first step, A plus C. While doing that, you realized that, can you see a overlap here? You added 2 times this region. So first of all, you subtracted that A intersection C. Okay. Then what you did is you said that this region is also unnecessary and also this region unnecessary. So what are those regions? A intersection B and B intersection C, isn't it so? This is A intersection B, this is B intersection C. So you subtracted A intersection B and B intersection C. While doing the subtraction, you realize this region got eliminated twice. So you needed 1 time. So you did the addition. And you are like, finally, I got my answer. Okay. Yes, this is the correct answer. But a smart student will say, or if suppose I manipulate this thing, suppose I add plus B and I do a subtract B, you will get the method 2 also. Sir, this formula I have seen somewhere. A plus B plus C minus A intersection B intersection C B intersection C addition of. Sir, this is A union B. And then you are doing A union B minus B and you got the answer. Yes, that is the method 2. Understood? So I hope you are seeing the method 2 in front of you. But what you did was you did this method 1. Okay, so method 1 is also good and method 2 is like this to get the answer fast. So if you want to visualize this, it looks like this. I took the complete region A union B union C. I took the complete region. From that, just eliminated the B region. This region I just eliminated. So what is left is the yellow region, that is the requirement. Understood? Try the next question. How you will formulate this? Think. Now since you are mastered enough to get the answer, I know you can do it. Okay. So you are thinking of A union B union C right now. You can think, but what I feel easier is, see this here, A plus C. If I do A plus C, so this is our A. Okay, and then this is our C. Then what is happening is, sir, in this overlap happened where? In the intersection A intersection C, and you eliminated that. Okay, but then sir ji, this region is not needed, so subtract with A intersection B intersection C. So this is what your final answer looks like. Okay, this is a method 1. Method 2 is, sir, I have seen this somewhere. A plus C minus A intersection C, isn't it A union C? So yes, your final answer is A union C, which means the method 2. Okay, so when I say final answer, which means method 1 was also good to go, nothing wrong in this. But if you visualize carefully, then this is what your simplified answer looks like: A union C minus this intersection. That's all. Understood? Then try this question. There are multiple ways to solve. I am not letting anyone down. I am just giving the smart approaches. If you see in the different lens, the big things get simplified, isn't it so? This big thing got simplified in this small thing. Similarly here also, this big thing got simplified into this 2 small things, right? So try this question. Sir, it's simple, right? It's B intersection C region, subtract the all common region. I got it now. B intersection C minus A intersection B intersection C. So yes, that's it for today. I hope you enjoyed the class. You got the mastery. You can also by heart these things. If I need this region, I can visualize B intersection C minus this thing. If I need this region, then what is A union C, and then this common part you can erase, right? So A union C you do, and then you subtract A intersection B intersection C. Or else you can say in this way also, a plus c overlap, one time you do the subtraction because two times overlap was added, so one time subtraction. And then this also you want to eliminate, so again a subtraction. It's up to you, wherever you feel the convenience. If you can by heart, well and good. If not, go with the manual ways. Here also you can say this one is actually easy, nothing to by heart, the complete region minus the b region. Otherwise this is good to go as well. And then if you need only a, what is the answer? Take the a, then remove this. While removing, what happened? Two times this middle was removed, so add one time. So it's very easy. And then this is also good. If you need the a union b union c, you can also think of in this way, universe minus the outside region. Outside region is a dash intersection b dash intersection c dash. Or else you have method 1 to go. Okay, this is also a good way, the De Morgan's and the complements of the world, which you can use to get the answer. Okay, and complete inclusion exclusion principle I have explained, and I hope now you got the crystal clear clarity on the feeling, on the formula remembrance, on the questions, on the various types of questions which can be framed. Thanks for watching this class.